Okay, today we're going to be talking about angular speed, and linear speed, and how they relate to circles, and how we can use radians to calculate them. So, please watch the video on the next page, and then we'll do some example problems.
We're going to start this lesson talking about straight line linear speed. So imagine you have a car. It starts from one point, goes to another point. In order to calculate the speed of that car, you would have to know the distance, and you would have to know the time. So the speed of something, otherwise known as its velocity, is the distance it's traveled divided by the time it took to travel that distance. It's easy to remember that because the units you usually think of for speed are miles per hour. So it's miles is a distance, hour is a time, distance divided by time. The shorter way to write that is V equals S over T, where V stands for velocity or speed. S is distance, because remember we did that around distance around the circle is S, and T is time. Now let's talk about angular speed. Angular speed is defined by the speed of an object moving around a circle. So if you look at that, the object moving around a circle, if I made a line, okay, that line is a changing angle. Okay, an angular speed, which is used, so the angular speed, I'll put this, is the angle change actually, so 0, 180, 360, divided by the time it takes for the angle to move that far. So, to show it another way, angular speed uses the Greek letter omega, that's the little curly w. So omega equals theta divided by t, where theta is the change of the angle and t is the time. Okay, so that leads us to this page where these two formulas exist. Omega equals theta over t, and v equals s over t. But look over at that linear speed. S we have another formula for. S equals r theta. So I could also say that v equals r theta over t. And we know that theta over t over there is angular speed. So we could write that still yet another way, and write that v equals r times omega. Example 1. Suppose that a point P is on a circle with radius 10 centimeters and ray OP is rotating with angular speed pi over 18 radians per second. A. Find the angle regenerated by P in 6 seconds. B. Find the distance traveled by P along the circle in 6 seconds. And C. Find the linear speed of P in centimeters per second.
Okay, so we're going to solve that problem now, and I'm going to do it backwards, and look at that dance. Oh yeah. Okay, so the first thing we're going to do is we're going to draw that circle. So there's the circle, okay, and it's got a radius of 10. Okay, now on that circle there's also a ray OP. So let me label point O, P, okay, draw that ray, and point P, point O is the center, okay. And that ray right there is rotating around the circle at pi over 18 radians per second. So we're going to use a formula to solve point A. We're going to use omega equals theta over t, because we know omega is pi over 18 and we know t is 6. So I'll set that up. That means pi over 6 equals theta, pi over 18, I'm sorry, equals theta over 6. Multiply both sides by 6. That 6 and that 18 are going to cancel out, as over 2 6's on the other side. Okay, that's going to give me that pi over 3 equals theta. I'm going to use that on part B. On part B, we're going to use S equals r theta from the other chapter, because we know that r is 10, and we just found that theta is pi over 3. Okay, so put it in. S equals 10 times pi over 3. Which is pretty simple, just means S equals 10 pi over 3. And that's the answer for B. Now for part C, oh, I'm showing you the answer for B still. Look at me. Okay, for part C, we're going to use the formula that V equals S over T, because we know S and we know T. We know S is 10 pi over 3, and we know T is 6. So it's 10 pi over 3 over 6, okay, which is the same thing as 10 pi over 3 times 1/6. Okay, that's going to give me 10 pi over 18. And that fraction simplifies because 2 goes into 10 and 18. Although I did that wrong, I put 5. And I divided 10 by 4 and got 18 by 2 and got 6. It should be 5 pi over 9. But I'm not doing this again. So that should be 5 pi over 9. And we'll have the answers for all.
Example 2. A belt runs a pulley of radius 6 centimeters at 80 revolutions per minute. A. Find the angular speed of the pulley in radians per second. B. Find the linear speed of the belt in centimeters per second.
So this is what part A tells us. Part A tells us that the pulley goes at 80 revolutions every 1 minute. But that's not good enough. I want to know the revolutions in radians per second. So I have to figure out a way to get this to work. So I need to convert radians to revolutions to radians, and I have to convert minutes to seconds. Minutes to seconds, because I want it in radians per second. Radians per second. Not very hard. How many radians are in 1 revolution? Well, 1 revolution is 360 degrees, which is 2 pi radians. So multiply that times 2 pi. On the bottom, I need to get from minutes to seconds. There's 60 seconds in a minute, sorry. So multiply the bottom by 60. Okay, that's going to be 160 pi over 60 radians per second. But that's clearly not simplified. Easy enough. I know they both divide by 10. So that leaves us 16 pi over 6. I can still simplify that because they both divide by 2. So then radians per second, the angular speed is 8 pi over 3 radians per second. Now part B. Okay, this is one of those formulas that we found in the slides for angular speed is r omega, which is great because I know r and I know omega. In the problem, we were given that r is 6 centimeters, and we found in the previous part that omega is 8 pi over 3. So that means V equals 6 times 8 pi 3. Fantastic. 1, 2. They cancel out. That leaves me with 8 times 2, which is 16 pi and the centimeters per second.
Example 3. A satellite traveling in a circular orbit of 1,600 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. A. Approximates the linear speed of the satellite in kilometers per hour, and B. Approximate the linear distance the satellite travels in 4.5 hours.
The satellite problem is classic because they always try to get you on this. We're going to pay attention to it. They tell us that the radius of the Earth is 6,400. So from the middle to that is 6,400. The trick is they think you're going to use that as your radius, but it's not because the satellite is orbiting not on the surface of the Earth, but it's orbiting how far up? I'll read it. 1,600 feet up. So there's another 1,600. Okay, so the actual radius of the circle from the middle of the Earth to the orbit is 6,400 plus 1,600, which is 8,000. Okay, so we need to calculate the linear speed of a satellite. So what do we need to do? All right, well, S equals r theta. That's what we're going to use because S is linear speed. S is not linear speed. S is position. Okay, right. V equals S over T. In order to do that, we know the time because we got the 2 hours, but we don't know the S. So we have to use r theta, and we're going to use it as 1/4 revolution because that's what it tells us. It tells us the speed of a satellite. It takes us 2 hours to make an orbit. So we know from here all the way back around is 2 hours. So that gives us the time, but we need to know the distance that is. So r is 8,000. So this is S equals 8,000 times 2 pi, so it's 16,000 pi. And I know it says approximate, and I will do that, but I'm going to do it after I write the rest of the problem. So now I can take this S and plug it into there. It's precisely what I'm going to do. That gives me V, which is what I'm looking for, equals 16,000 pi over 8,000. And that's what I'm going to plug into the calculator that I don't have. Wait a second. Okay, so now I'm back with my calculator. I got 16,000 for the thing. 16,000 is S, and T was 2 hours. Okay, so that means to get the speed of a satellite in miles per hour, all I have to do is do 16,000 pi divided by 2. That's going to give me 25,132 miles per hour, which is an approximate, or 133. So but it was 0.7, so I have to round up. Miles per hour, and that is my answer. Now for part B, I'm going to take this information and the 4.5 hours and see how far the satellite goes in 4.5 hours. So V is still 25,133. Don't know S, but I know T is 4.5. Well, I just multiply both sides by 4.5 to get my answer. Well, let me teleport over there. Okay, so I measure the 4.5. Okay, times both sides by 4.5, which I do. That gives me that number. So I write it down. That means S equals 113,099 miles. And that's the answer part B. That's the end of the lesson. Goodbye. I said goodbye. Bye.